Good evening, everyone. So, today is chapter 6. The title for today's discussion is Foundation of Business Intelligence under the topic Databases and Information Management. With that, let me get started with the details. The learning objective for this chapter are such as: first, we need to describe basic file organization, concept, and the problems of managing data resources in a traditional file environment. Non-database environment. Next objective is to describe how a database management system, or in short we call DBMS, information and compare the principal database models. There are various database models available, so we will see what is DBMS and what are the models available to be compared with. Moving on, the next learning objective will be on apply important database design principle. So we will look at the design of the database. So we're going to start this lecture by giving you some file organization terms and concept. For some of you this is not new, but for some of you it is maybe you are hearing this for the first time. So let me consider everyone at the same level and start from ground zero. The first term is bit, or we call it BIT, which is the smallest unit of data. The word bit is actually a abbreviation of binary digit, BIT, binary digit, which is actually referring to the 0 and 1. So as far as binary digit is concerned, there are only two numbers which we call bit, 0 and 1. Reason this is how the data is finally transmitted or converted into before the computer system can understand your data. Even though we are writing it in text or in audio or video, but end of the day the computer only can understand bit, or what we call the smallest unit of data, which is in binary digit, 0 and 1. I believe we have more data to look at. Next is the term byte, which is a group of bits that represent a single character. So in an older system we call 1 byte equal to 8 bits. 1 byte equal to 8 bits, or 8 bits makes up 1 byte. That is the size that we normally refer to. For example, let's say a single character A will be represented by 8 bit. 8 bit. What are the combination of the 0 and 1? It depends, but it consists of 8 bits which make up of 1 byte. But we will look into that into more detail later. As the computer advances in terms of technology, in terms of architecture, the size, the processing speed, the power of the computer system also increases, as we discussed in our previous lecture, where those days the computers was under 8 bits or 1 byte of architecture. Later on moved into 16, 32, and now we even have 64 bits architecture computers. So there are a lot of details attached to it, which we will discuss to some extent, not too detailed, for your information. The next term that we're going to use related to the file organization, terms and concept, is what we call field, which I believe all of you are very familiar with. Group of words or a complete number. So that is a field. I will show you more example later. And of course record, which all of you are familiar with. Group of related field. group of related field. For example, if it is customer, is the customer name is the field, customer contact number is the field, a group of customer ID, customer name, customer contact number, and so on. Related field, this is what we call related field, belong to a similar record. And next to the record, the term that you need to know is of course file, which is a group of records of same type. All these terms are quite important for us to understand the traditional file organization method, as well as moving on to discuss databases or DBMS system. In the next slide, what we have are the terms which are very much related to databases. For example, the very first term that we have is what we call database. So what is database all about? A group of related files. Remember earlier we discussed about files, group of records of same type. So now databases consist of a group of related files. For example, if we call it customer database, then it has all the related files to customers stored or saved into this particular database. The next term that we have in our list is what we call entity. Entity, or sometimes in other or in traditional file system, we also can refer to a object or a file, for example. But in database or in DBMS, entity, we refer to the same thing, but we call it, like, for example, person, a place, think, event about which information is maintained. All this is known as an entity, which is not a new term, or which is not a abnormal or unheard terms. For some of you, it may be a quite a normal term, which is entity. Entity means is like a file, an object. And then we have attribute, which we can compare to field description of a particular entity. For example, we have person, then we have person ID, person name, person address, person contact number. All those we can call it as attribute as well. But in DBMS, we use different term compared to traditional file method, or traditional file processing, or traditional file organization method. And in DBMS, the field we call key field or attribute. And what is key field? Key field is actually identifier field used to retrieve, update, or sort a record. This is like a main key, primary key. That is what we call key field. So we have attribute belong to a particular entity or object or file. So this file, object, or entity must have a key field. For example, if it is a person, person ID can be the key field. If we have a place, place ID, for example, can be the key field, or we call it the primary key. And of course, primary key also being supported, or sometimes we do create what we call a secondary field, and also foreign field, or primary key, secondary key, and foreign key. So all these are the terms that we use for DBMS systems. Okay, now we understand all the terms. This is an example of how data is organized in a traditional file environment. In our normal file that you use in your business. For example, you have a customer file, supplier file, patient file, and so on. So the highest level in terms of hierarchy is databases or database. Then we have file. File consists of many records, thousands of records, hundreds of records, millions of records. Then records consist of field, field consists of byte, byte consists of bit. So that is the hierarchy. That is hierarchy, and examples are given for you to see. For example, the database consists of related files. We have cost file, financial file, personal history file, and so on in one database. Follows with each file, for example, the cost file, you take it out, it consists of many records, and each cost file consists of many records, and each record consists of many fields. This is just one record, consists of many fields, and each field is what we call, for example, the name is one field, and this name consists of many characters. Each character will be represented by the byte, 8 bits, and how they decide, or who decide what are the 0 and 1 to represent a single character. It is all in a table which is known as ASCII table. ASCII table is American Standard Code for Information Interchange. It is a table created by organization in US to represent all the characters that we have on our keyboard. So this table can be downloaded from the internet, which I don't have here to show, but you can easily download from the internet, and you can see what are the characters and what are the binary code for each of those characters. Okay, just to share with you some information, and bit is either 0 or 1. Alright, with that, I hope you have a very good understanding now in terms of the data hierarchy. It starts from bit, byte, field, record, file, and database. Okay, so this is an important understanding for today's discussion. Let me just keep you informed on this. Today's topic, beside last week's topic, is going to be slightly technical, maybe not for all of you, but for some of you. Just give me a minute. Not for all of you, but for some of you. If you need any further explanation, please stop me. Please stop me. I will always try to help you. Otherwise, as usual, I will continue with my lectures. Reason there are 55 slides, I need to complete, if possible, all the slides with you guys today. Of course, there are a lot of information. Some are quite technical. That's the reason why I have just mentioned. If you need further explanation, please stop me. I will explain to you. What we see in our next slide is entities and attributes. For example, the entity is order. It's like a file, and it consists of attributes of fields such as order number, order date, item number, and quantity, and it has data. Belong to each field, and out of all that, the order number is the key field, the primary key. Just to give you an example. As usual, we have a problem to be discussed over here with the traditional file environment. Let's look at what are the problems. The problems are related to data redundancy and inconsistency, especially in the traditional file environment, in our traditional file organization. What is data redundancy? The presence of duplicate data. The same data exists or appears in multiple data files. So that is can be a real problem, because we are storing the same data in multiple files. That is not good, and it appears in many different files, which creates a duplicate. Also, when can create a lot of waste of the data file space, and a lot of effort need to be taken to maintain this duplicate data, which we wish we should not have this. So that is the problem with the traditional file. The other problem is due to data inconsistency. the same attribute may have different values. Reason these fields might appear in more than one file because it is all normally physical file or paper file, not digital. Some of the files are still digital, but they are not in a database environment. For example, you open up an Excel file and you save it as an Excel file, not onto the database, onto a normal C drive or your external hard drive, for example. So that is also known as a traditional file environment. Only when you store the file onto a databases, we call it is belong to the database environment. But if your file is in a non-database environment, it still goes back into what we call traditional file environment. So I want it to be very clear what is traditional file environment and databases. When you simply create Excel, PowerPoint, Word, Access, and you save it as it is, not onto a database environment, that those files are still under what we call traditional file environment, yeah, because it is a standalone, and this is where it can create data redundancy and inconsistency. Moving on, what are the other problems with the traditional file? Includes program data dependence, what we call the coupling of data stored in files and in the specific program needs update, needs update to maintain the changes, especially when these files are being used by different people. They might do changes, yeah, and these changes sometimes duplicates, or the person has done changes in one file but forget to update the changes on the other files. So it can cause problems. For example, supplier file might be used by two different departments or three different departments, but one department do a changes, but then maybe the other departments are not aware of it or not being informed, then their data or their thinking or their understanding is still with the old data. So that is one of the problem with the traditional file, yeah, because different department will see different data when they start using the same file for different purpose. So there is a no what we call updated or real-time update, or what we call program data dependence is not taking place in such cases. That is another huge problem with the traditional file environment. The next problem that we have with such environment is what we call lack of flexibility. Yeah, lack of flexibility. So in this traditional file environment, reason there is no automation or no much of programming efforts involved. So the problem is reports cannot be generated automatically, yeah, or reports will be some kind of outdated report because the data itself is not really updated. It could be old data, yesterday's data, or outdated data. So you cannot immediately generate report based on those data, and there is no facility available to generate report unless you create one, yeah, or you have a mechanism to schedule report. Otherwise, creating report is a separate task in a traditional file system. And in order to generate report, normally what we do a lot of filtration, we do a lot of sorting, indexing, and so on. And all those capabilities are normally not automated or not available in a traditional file environment compared to database environment. So it's a bit complicated. I hope all of you can follow me. Otherwise, you please stop me. I can explain further by giving more examples, but like what I said, I don't have much time to go beyond what we have on the slides. uh, I need to follow strictly what is on the slide, unless question brought up by you or you need further clarification or explanation. uh, Moving on the same topic, problems with traditional file environment, definitely security. There is no security, or what we can say, little control or management of data is not really secure. We are not really in a very safe environment. Reason, you are simply opening up or creating a file in a standalone mode, and you are saving it onto a uh, hard drive. Unless your tablet or your laptop or your PC is secured, protected with password, then it is acceptable. Otherwise, if it is not, for example, if you are using any domain, public domain, or if you are using any public PC, then your files will be exposed to anyone who have access to the same device. So there is a poor security. Some traditional file allows you to create password, but that is again tedious. Yeah, every time you open the file, you need to enter the password, and if you forget the password, it's very difficult to recover. But all this will be taken care in a database environment. The next problem that we have with the traditional file is what we call lack of data sharing and availability. Yeah, because the file is a standalone file. So what is happening here is, in order to share the file, you have to give a additional sharing features. You have to set it up. So it's not that straightforward. And when you share such a file, only one person is allowed to edit the file. When the other person is trying to share or access the file, this person will run into read-only mode. So that is difficult, cannot be managed under what we call a traditional file architecture. But if it is databases, databases files can be accessed by any number of people, any number of users without any issue, and the accessibility will be managed by the DBMS system. So that is the beauty of the DBMS system compared to traditional file. I hope all of you can follow me on the lack of data sharing and availability when we compare the traditional file system with the database. Okay, what you see on your next slide is actually a traditional file processing mechanism. For example, on your left hand side, you can see all the files. We have accounting and finance file, human resources, HR related file, sales and marketing file, manufacturing files. So we have the dedicated users for all these files, and they use their own related application. For example, application program 1 related to accounting and finance, and so on. And there are derivative files belong to that application program, as you can see, A, B, C, D, A, B, D, E, A, B, E, G, and so on. So some files are being used by more than one department, like for example, the file A are being used by all the department, as well as file B, but some files are only being used by that particular department. So the issue here will be with the files that used by different department. So if they update, for example, accounting and finance update file A, there is a high possibility that HR department or any other department who are using this file as well can go unnoticed or unaware of the changes done by the accounting and finance, because it is a standalone file and it is on a standalone environment, not on a database environment where everybody can see the changes immediately on real time, but this is happening only to that standalone file, and that can be a big problem. Later, when human resources open the file and they find there are a lot of changes, for example, done by accounting and finance. So this can be a surprises for the human resources and other department as well. That is the reason why when you have a network environment, more users, you need to have a DBMS or database environment instead of working on a standalone environment to avoid such a problems like what we have seen earlier. Yeah, we have number of problems with the traditional file processing system. So with this understanding, let's move on and cover a couple of slides before we take a break. There are a lot of information that I'm being shared with all of you, so I would like to go slow instead of too fast, and then we don't understand what is going on. Okay, next what I'm going to do is I'm going to continue with the database management system. In short form, we call DBMS. So there is a software for creating and maintaining databases. Like what I shared with all of you in the previous lectures, I did touch on DBMS. We have various types of DBMS available in the market today, starting from as simple as MS Access, Microsoft Access, which is part of your Office, the simplest types of databases. We have MySQL, or we call it MySQL databases. We have Oracle high-end databases. We have DB2 high-end owned by IBM or proprietary kind of databases. We have many other types of databases that owned by many IT companies, which can be purchased, which can be leased for our use. So in other words, there are very specific software available for creating DBMS, but we need to purchase. Nothing is really free. And this database or DBMS, why we need that? Reason to manage data for the entire firm, not for a particular department or individual, but normally we purchase DBMS platform to manage data for the entire company. So this DBMS acts as an interface between application program and physical data files. So if you have any physical data files, you can always migrate, you can always transfer all the data into a online file system into the database and make it a DBMS file, which can be accessed by more users from different departments, and it will become part of the DBMS instead of traditional file. DBMS also allows us the file or the environment to be managed as logical and what we call design views of data, meaning we can have a design and then later on we can, based on the design, a file design or database design, we can convert that design into a logical file, meaning online file, and then we will start saving into the DBMS and use DBMS software to manage it. So with DBMS, with the availability of the DBMS, it solves many problems, or we can overcome many problems that we have with the traditional data file approach. So this is an example of what we call contemporary database environment. So on the left hand side, what you see are all the entities. For example, we have employees, payroll, benefit, and we might have supplier services, and so on. So we have all the entities here. We have all the departments within a company, and all this data belong to these departments, belong to these entities, will be stored into the DBMS. Will have a link. Yeah, we need to migrate all this data into a DBMS system, and by using the DBMS system, we can create a separate application that will manage different department, or that can be used to manage different department. And there are many custom software like what we have seen in the previous sessions, which are being used by a very specific department. For example, payroll application program by the payroll department, benefit application program by the maybe benefit department or under the HR, and then we have a personal department just manage the personal employee data. So this is how the DBMS can be used to manage all the data that have been entered according to the different application, different department, in a very structured manner. So it has the software and capability and features for doing so. That's the reason why we need to purchase the database. Yeah, and some of the databases, especially the high-end databases like Oracle and DB2 or Informix, for example, are very expensive, but it requires like one time or planned investment for the firm to own it, but it is for a long-term usage. Yeah, for a long-term usage. Okay, let's look at components of DBMS. This slide is slightly consists of some technical terms. The first component is known as a DDL, or we call data definition language. So what is DDL? It specifies content and structure of database and define each data element. So it is actually a language. It is actually a database language that the database programmer or the database administrator will use in order to specify the contents and in order to create the structure of the database for each data element. For example, customer data separately, supplier data separately, and so on. The next component is what we call data manipulation language, DML, used to process the data in databases. So once all the data are available in a proper appropriate structure, this database administrator, or we call DBA, database administrator, DBA, will use DML language to process all the data in the databases, so that the data will become meaningful and we can start using it for our business. The next component is what we call data dictionary, or in short form we call DD. What is DD, or data dictionary? As the name specifies, it stores definition of data elements and data characteristic into either passive and active. Passive meaning the data is there but it is not active or not in use, but active means the data is there and it is actively being used by users, by someone. So these are three important components of any databases or DBMS: DDL, DML, and DD. An example of sample data dictionary report, it consists of much technical details about the data. For example, we have amount, pay, base. Focus name is base pay and the PC name is salary. So this data is in that particular device. Description is there and the rest of the details such as size, type, date, ownership and so on. So these are the technical details about the data, which is known as amount, pay, base. So all this data will be keyed in by the DBA or by the data entry clerk into the database, into the DBMS, and they will create what we call uh, uh, logical design of the file of the entity using the DDL, DML, and data dictionary, so that it will become meaningful to be processed, to be used to generate report, to generate inquiries, to pull out more data from the databases, so that we can use it for the business purpose. So that's how the DBMS works. All right, so what I'm going to do, let me cover one more slide before we take the break, one or two more slides before we take the break. We're going to look at the types of databases available. Yeah, after going through the important components of the databases such as DDL, DML, data dictionary, and there are many more terms related to databases. In fact, the DBMS is a very complicated environment. Reason it allows not only 100 but thousands of users use the same file at the same time, and the DBMS system makes sure the file is updated on real-time basis. For example, let's say in a company there is a one file, for example, patient file, and you have 100 over branches throughout the country. So anyone accessing the file at that particular time, the latest information related to that patient need to be updated, need to be displayed. That is the role of the DBMS, and this cannot happen in a traditional file system unless someone is sitting there and updating the file on real-time basis. Again, it cannot be really real-time, it only can be online or with some delay. But in DBMS, it happens on real time. That is the beauty about DBMS. Another example is, for example, airline ticketing system, where you are booking a ticket online, and that information will be immediately updated across global, if it is a global based airline company, so that everyone is aware, everyone can see the data is actually, or that particular seat is already booked by someone from one particular country with all the details, so that there is no another person booking the same seat, for example. So that is the role of the DBMS, and that is how important is the databases in our businesses. So that's the reason why big organization, they will go for complicated or sophisticated databases such as Oracle, Informix, IBM too. For example, government department, government department such as finance department, national registration department, road and transport department. Normally they will be using huge types of databases. Reason they are dealing with millions of records in a day, and they need to make sure all the records are up to date, so that there is no data redundancy, there is no data duplication, there is no inconsistency in terms of data or in terms of information. So that's how it is important to understand DBMS or databases. So I hope I'm giving you a very clear picture to what is DBMS and what are the examples of environment available outside. And moving on, we have a long list of slides which will really help us to understand the DBMS in more detail. So with that, before I start continuing on